In this example, we have a bicycle that we know that in the x direction it has a velocity of 5 feet per second and it's constant, and it's traveling over a horizontal curve on a road that's represented with the function y equals 0.008x minus 8 times 10 to the minus 6th x squared. And we want to find the x position, the y position, the velocity in the x, the velocity in the y, the acceleration in the x, and the acceleration in the y at a time of 60 seconds. First of all, we know that the velocity in the x direction is equal to 5 feet per second. That was given. And we know that it's constant. So I can represent my position x as being equal to my initial position, which is 0, plus my initial velocity times the time, 5t, plus 1/2 my acceleration, which in this case, if I've got a constant velocity, then my acceleration is 0 times the time squared. So this term will drop out, that term will drop out, and I've got that my x position is equal to 5 times the time. Next, I need to relate my x and y velocities. So I'm going to start with my equation y equals 0.008x minus 8 times 10 to the minus 6 x squared. If I differentiate this equation with respect to time and do it implicitly, then I would have the derivative of y with respect to time is equal to 0.008, the derivative of x with respect to time, minus, bring the 2 down for my x squared, so I would have 16 times 10 to the minus 6 x, and then I have to use chain rule and take the derivative of the inside, which is dx dt. We know that dy dt, the derivative of y with respect to time, is equal to the velocity in the y direction, and the derivative of x with respect to time is equal to the velocity in the x direction. So let's just rewrite this in terms of velocities. Vy is equal to 0.008 Vx minus 16 times 10 to the minus 6 x Vx. So there's one equation that relates my velocity in the y direction to my velocity in the x direction. And as long as I know what my position is, I can find what those velocities are. But I don't have anything in here that will help me with acceleration. So let's take the derivative of this function again. Again, we would have the derivative of the velocity in the y with respect to time is equal to 0.008 derivative of the velocity in the x with respect to time. Now I've got an x term and a velocity in the x term, so I'm going to have to use the product rule here in order to take this derivative. So with the product rule, I'm going to take the derivative of the first times the second plus the derivative of the second times the first. So the derivative of the first, minus 16 times 10 to the minus 6. This will be dx dt, which is the velocity in the x direction. And that velocity times this velocity would give me the velocity in the x direction squared. Now, the derivative of the second times the first, 16 times 10 to the minus 6th x, and this would be dvx dt. However, we know that the derivative of the velocity with respect to time is the acceleration. So my acceleration in the y direction is equal to 0.008 acceleration in the x direction minus 16 times 10 to the minus 6th velocity in the x direction squared minus 16 times 10 to the minus 6th x times the acceleration in the x direction. However, we determined up here that since my velocity in the x direction is constant, my acceleration in the x direction has to equal 0. Therefore, this equation reduces down to ay is equal to, this term cancels out, this term cancels out, minus 16 times 10 to the minus 6th times the velocity in the x direction squared. There's the next equation that I'll need to be able to solve this problem. Now, knowing that x is equal to 5t, I can plug that in to my velocity equation here. I know what my velocity is in the x direction. We said that that was 5 feet per second, and I can plug that in for my velocity here, and I should be able to find my velocity in the y direction at t equals 60 seconds. So, plugging that into my velocity equation, I get that the velocity in the y direction is equal to 0.008 times 5 feet per second minus 16 times 10 to the minus 6th times x, which in this case we've got 5t, and we're looking for velocity at 60 seconds, so 5 times 60, that's my x position, times the velocity in the x direction, which is 5. Solving this out, I get that the velocity in the y direction is equal to 0.064 feet per second. So I now have my two velocities. I can find what my x position is by simply plugging in my 60-second time into this equation. So x is equal to 5 times 60, which is equal to 300 feet. Just so that I keep track of things and what I've already completed, I'm going to go ahead and double underline my velocity in the y direction and mark that in the margin, and I'll double underline my x position and mark that in the margin. I can also double underline my velocity in the x direction and mark that in the margin. As I've already stated, my acceleration in the x direction is equal to 0, so I can also mark that. So I have my velocity in the x direction up here at the top, my velocity in the y direction, my x position, and my acceleration in the x direction. So I just need to get my y position, and I need to get my acceleration in the y direction. To get my y position, I can go ahead and plug in my x value into this equation and solve for y. So y is equal to 0.008 times 300 minus 8 times 10 to the minus 6th times 300 squared, which equals 1.68 feet. That's my y position. Now all that's left is to find my acceleration in the y direction using this equation and plugging in what I have already solved for. Acceleration in the y is equal to minus 16 times 10 to the minus 6th times my velocity in the x direction, which is 5 feet per second squared, which will give me an acceleration in the y direction of minus 4 times 10 to the minus 4th feet per second squared. So I have my acceleration in the x, my acceleration in the y, I have my x position and my y position, I have my velocity in the y and my velocity in the x. So that finishes my problem.